Hi doctor, I am Jeevamalar Vairavan. My metric number is 288844. In this video, I am going to present chapter 3 multiple integrals, which include the subtopics double integral, iterated integral, triple integral, integral under general region, area and volume under the bounded regions. And my presentation is going to be about double integrals. Double integrals are a way to integrate over two-dimensional area. So we can start to find the area of an rectangle, which is AB implies the x-axis and CD implies the y-axis. This means that the range of x and y are x is AB will be the x upper limit and lower limit, and y CD will be the upper limit and lower limit of the y-axis. This double integral methods is usually can be used by finding the volume and area of a bounded region, and the formula is shown below. Double sum method are one of the important rule in this double integral. The formulas are shown below. Each rectangle has the base area of delta area and height of fx, so that the volume of each boxes fx can be found easily. To get the better estimation, the value will take n and m larger limits. To get the exact value, we'll need to take and both limits n and m to go to infinity. In other words, we can see these formulas.
Now, to make it better understanding, let's go through this example. The given question is, estimate the volume of the solid that lies below the surface z equal xy and above the rectangle xy, x limit is 0 to 6 and y limit is 0 to 4. The question is asked us to use a Riemann sum with m equal 3, n equal 2 and take the sample point to be the upper right corner of each subrectangle. First of all, let's take out all the given information. We know that z equal to xy function, and then the limits of the rectangle is x is 6 to 0 and y is 0 to 4. So now we can start to sketch the graph. The x limit is 0 to 6. So the horizontal axis will be 0, 1, 2, 3, 4, 5, 6. And then the vertical axis, y-axis, is from 0 to 4, which means 0, 1, 2, 3, 4. And then we are given the information m equal 3 and then n equal 2. This is mean that m is referred to column, this is 3 column, and n is referred to row, which is 2 row. So now from this graph we can sketch the column is 3, and then the row is 2. We can take 2 and 4 from this graph. Now we already find out the rectangle. We have the 6 small rectangle from this graph. The question is also given the clue that take the sample point to be the upper right corner of each subrectangle. We have 6 subrectangle, which is 1, 2, 3, 4, 5, 6. Upper right corner is the corner point of the each rectangle, which is in the right hand side. Means 1 from this rectangle. From this rectangle is 2, and this rectangle is 3, this rectangle is 4, and this rectangle 5, and this rectangle is 6. So for now, we already got the 6 coordinate of this rectangle. From this solution, we can use this formula, which is to find the volume. We can use the summation of n I equal 1 summation m j equal 1, which means the function xi and xyj times by alpha, area, delta area. To make it easier, first we take all the coordinate points of this graph, and then we can take our function of this graph, which is x times y. Okay, first coordinate point we get from here is 2, 2. So we get 4. Second coordinate point is 4, 2. We get 8. Third coordinate point is 6, 2, which is we get 12. And then we go the next point, we get 2, 4, 8, 4, 4, 16, and lastly 6, 4, we get 24. The formula said to find the volumes, we get x times y. So the summation of m and x is, if we total all of this, we'll get the coordinate 72, the total volume. So now the formula of this function is we need to times by area, the upper area. So our a is equal to, delta a is equal to 4, and finally we can times the area with 4. We will get, using the calculator, we will get 288 units. Now let's look at the example of finding the volume under the bounded region. Given the question that find the volume of the solid that lies under the paraboloid z equal 9x square plus y square and above the z equals 0 and bounded by the x equals 0, y equals 0, and upper limit is x equal 3 and y equal to 2. We know that to find the volume of the double integral, we use the formula v equal the double integration z over dv. So for now, our first limit is y, which is upper limit is 2 and lower limit is 0. So from 0 to 2. Next, the x limit is from 3 to 0. And then our given function is 9x square plus y square. And now we need to find the dv. So our integration will be dx over dy. So first we need to integrate the dx. So let's separate the dx from this function. So s to 0, 9x square plus y square dx. When we integrate this function, we will get 9x cubed over 3 plus xy cubed integration 3, 0. We will get 3x cubed plus xy cubed 3, 0, 3, 27 plus x 0 cubed times 3. We will get 81 minus 3y cubed. Next, we integrate this to the next function, which is s 0 to 2, 81y minus 3y4 dy. We will get 81 times 2 plus 304, 16, 162 minus 12. The answer is 150 unit cube. This is the volume of the area under the bounded region.